Welcome, this is Dr. Amanda Ratkinson-Zapke, and in this tutorial we are going to use SPSS, which you can see I have opened here, to examine two assumptions, the assumption of no extreme outliers and the assumption of normality. Here you can see I do have SPSS open. We can see that I have in these first two columns the independent variables, type of program, and gender. Then I also have three dependent variables. These two dependent variables, learning community and community connectedness, are actually subscales that make up our dependent variable sense of community, which we'll be concerned about in this set of tutorials on a two-way ANOVA. Now, as I said, we are going to examine two assumptions in this tutorial. For all levels of the independent variable, we need to determine if the dependent variable is normally distributed. We also need to make sure, remember, that there are no outliers. First, to examine outliers. For each dependent variable at each level of the independent variable, we're going to create box plots. In order to examine the normality assumption, we are going to conduct normality test. We could also use histograms, but we're going to conduct normality test. And we're specifically going to conduct a Shapiro-Wilks rather than Kolmogorov-Smirnov, since we have under 50 cases per group, which I'll demonstrate once we get to the output. So to do this, we are going to click Analyze, Descriptive Statistics, and then Explore. Here we are presented then with the Explore dialog box. We are going to click the dependent variable that we're concerned with here, total sense of community, and use the arrow to move it over to the dependent list box. Next, we're going to move the independent variable, type of program. We're going to click on type of program, we're going to click on this arrow, and we're going to move it over to the factor list box. We're going to do the same for gender. This helps SPSS know what to do. This setup specifically tells SPSS to perform all the procedures we select on the dependent variable for each category of our independent variables. Now we need to tell SPSS what to do and what we want the output to include, so we're going to click Plots. And we are presented with the Explore Plots dialog box. We're not interested in the stem leaf plot, so in the descriptive area, we're going to deselect the stem and leaf plot by clicking on it. We are then going to click on Normality Plots here, as this will tell SPSS to conduct our normality test, Shapiro-Wilks and Kolmogorov-Smirnov. If we wanted to use histograms, we can also click the histograms. In fact, I'll just go ahead and click histograms also. We're going to click Continue, and then we're going to click OK, which will tell SPSS to go ahead and produce output. Now, here you can see at the very top we have type of program. This is because SPSS separates the two independent variables. First of all, we're going to look at type of program, then we'll look at gender. To determine, first of all, whether we have any outliers in our data, we are going to look at the box plots for the dependent variable at each level of our independent variables. As I said, we're going to start with type of program. So I'm going to scroll down and find the box plots for type of program. Keep scrolling. Here is the box plots, or are the box plots for type of program for both online and traditional. Now let's talk a little bit about this output. Any data on the data points that is more than 1.5 box lengths from their box are classified by SPSS as outliers. And these data points are illustrated as circular dots and labeled with their cases. Now, if there are any data points that are more than 3 box lengths away from the edge of their box, these are classified as extreme outliers, which is really what we're concerned about here. And these are illustrated by asterisks, and again, they're labeled with their case number. So you can see in this example that we do have outliers as evidenced by some circular dots. There are none for the online group, but there are 3 for the traditional. Cases 29, 21, and 36 are outliers. However, they're not extreme, so we're not too concerned about them. Next, we're going to scroll down and look at the box plots for gender, both males and females. Here you can see we're now headed into the gender output. SPSS indicates gender here. So again, I'm scrolling down looking for the box plots. As you can see, SPSS creates a lot of output that we aren't going to use right now. Here are our box plots for gender. Here we can see that we don't have any circular points nor asterisks. Therefore, we can conclude here that there are no outliers. I will make a quick note here that there are multiple ways to check for outliers. So rather than relying on box plots, another method for checking outliers is to calculate studentized residuals and classify any of these residuals as that are plus or minus 3 standard deviations as outliers. So this is just one way to look at outliers or examine whether or not a data set has outliers, is to use box plots, but there are other ways. Now that we've looked at extreme outliers, let's move on and look at normality. We're first going to go ahead and look at normality for our type of program variable. So I'm going to go ahead and scroll up and find the output we need. Here it is. Okay. Remember that we are going to use Shapiro-Wilks because it's recommended if we have a smaller sample size, that is groups less than 50. In fact, I'm going to keep scrolling up here to show you that both our online group and our traditional group have less than 50 each. Our online group has 33, our traditional group has 43. Okay. Now we're going to scroll back down to find the results of Shapiro-Wilks. The results of Shapiro-Wilks, as you can see here, are presented in the tests of normality table for each level of the independent variable type of program. Let's go ahead and interpret these. What we're really concerned with here in the Shapiro-Wilks row, the Shapiro-Wilks column, we're really concerned about this significance column here. We want to know if the significance value for each test is less than or more than 0.05. Remember, non-significant results, that is a significance level of 0.05, indicates that normality can be assumed. If the assumption of normality is violated, the significance value will be less than 0.05. Why is this? Well, because the Shapiro-Wilks test is testing the null hypothesis that our data's distribution is equal to the normal distribution. So rejecting the null hypothesis means that the data's distribution is not equal to the normal distribution. Here we can see that both significance values for both online and traditional is less than 0.05. For online, it's 0.024. For traditional, it's less than 0.001. Therefore, we cannot say that normality is assumed. We violated the assumption of normality for both the online and the traditional group. Now let's go ahead and scroll down and take a look at the test of normality table for gender. But before we do that, we're going to look at this case processing summary table just to make sure that both of our groups have less than 50 cases. And here we can see that there's 45 females and there's 31 males. So again, we're going to use Shapiro-Wilks. And here again, we're going to look at the Shapiro-Wilks column for both of our groups. We're looking specifically at the significance column, and we're again looking for a significance level of above 0.05 to make sure that normality is not violated. Unfortunately, what we see here in this significance column is that the male group has a significance level of 0.03, the females less than 0.001. Therefore, again, for these two groups, both males and females, normality cannot be assumed. However, remember that the two-way ANOVA is reasonably robust to violations of normality when the group sizes are similar, and in our case, they're fairly similar. So what we will note is that the assumption of normality has been violated for all 4 of our groups. However, we can go ahead and continue with the two-way ANOVA.